One nice application of geometric series is converting repeating decimals into their rational form. Remember that rational numbers are, in decimal form, are decimals that either terminate or repeat, but they come from the ratio of two integers. If we start off with a ratio of two integers, for example, 1/3, then it's quite easy to find the decimal expansion by just doing some long division. And it won't take very long to discover that this is going to be 0.33333, and we just keep on getting threes over and over again. So that's the process of turning a fraction into a repeating decimal. But what about turning a repeating decimal into a fraction? Well, that's, believe it or not, where infinite series come into play. Let's look at 0.1 repeating. This is the same thing as 0.1 plus 0.01 plus 0.001 plus etc. forever. And you should recognize this as a geometric series. We have an initial value of 0.1 raised to the first power, and then we have 0.1 raised to the second power, and we have 0.1 raised to the third power, etc. So we could write this as the sum from n equals 1 to infinity of 0.1 raised to the n. Okay. We don't really need to do this last part, but just to tie it into what we've just been talking about, this is the summation notation. As soon as we recognize this as a geometric series, all we need are the a value and the r value. The a value is the first term, which is 0.1, and the r value is the thing that we're multiplying by each time, which is also 0.1. Notice that this is a value that's between -1 and +1, so this infinite series will converge as we would expect it would. So anyway, this value is equal to 0.1 divided by 1 minus 0.1, or 0.1 divided by 0.9, which is 1/9. And that is, in fact, the fraction form of the decimal 0.1 repeating. So that's kind of nice. We can try this with a slightly more complicated repeating decimal. This one has 2 digits in its repeating form. So when we rewrite that, we would say, oh, well, this is 0.27 plus 0.0027, and then plus 0.000027, etc. Now, we're not multiplying by 0.27 each time, right? Because then the digits would change. To get from here to here, we're moving the decimal 2 to the left, so we're multiplying by 1 over 100. Or 0.001, you can use either one. To get from here to here, we're again multiplying by 1 over 100. So the geometric series here has an initial value of 0.27, and an r value of 1 over 100. So we can say that s equals 0.27 divided by 1 minus, I guess I'll keep it as decimals. This is 0.01. So that's 0.27 divided by 0.99, or 27 over 99. And that reduces. They're both multiples of 9. So if we divide 27 by 9, we get 3. And if we divide 99 by 3, or by 9, we get 11. And 3 over 11 would be the reduced form of that decimal. And you can double check that by doing some long division and realizing that when you divide 11 into 3, you get 2, 7, 2, 7, 2, 7, 2, 7, etc. So that's pretty straightforward. Let's take a look at this last example. This throws one more kink into the mix here. We have not the entire sequence of digits is repeating, right? We've got this stray 1. So we can rewrite this as 0.1 plus 0.06 plus 0.006 plus 0.0006, and that follows the pattern provided we kind of keep that 0.1 out of the mix. Okay, so we're going to have an infinite series and then plus 0.1. All right, so this is going to be what are we multiplying by each time here? Well, we're moving the decimal 1 to the left each time. So we're multiplying by 1/10 or 0.1 each time. So that's our R value. So this piece right here is going to be, our first term is 0.06. Our R value is 0.1. So we're doing 0.06 divided by 0.9, or 6 over 90, and then we can divide by 3 to get 2 over 30, and then we can divide by 2 to get 1 over 15. That's just the 0.0 and then the 6 repeating. We're going to add this 0.1, but that's not so bad because 0.1 is 1/10. So if we have 0.1 with a 6 repeating, that's the same thing as 1 over 10 plus 1 over 15. And we can find a common denominator here. We'll multiply by 3 over 3 here, and we'll multiply by 2 over 2 here to get a common denominator of 30. So we've got 5 over 30, right? 3 plus 2 is 5. And then we divide everything by 5, and we get 1/6. So that would be the rational form, or I guess the ratio form of the rational value 0.16 repeating.